Welcome to the Emerging Exceptions entry to the 2023 Codejam. Within this video presentation, I will demonstrate the work each of us performed. Each of the following are our Discord tags. At FlonkDev worked on the front end, at deleted.user0 worked on the stenography, along with a numerical base switching function and the utils module imported into most of our work. At OK.and. worked on the datastamp decoding section, and I, at Verkekkening, primarily worked on the datastamp section, including encoding, decoding, and scanned image manipulation. Please note this is also known as pixel QR in the files, along with recording and editing this video. We thank you for this opportunity and hope you enjoy our work. Welcome to the UI section of the video presentation. In this video, I will demonstrate the UI code. Simply go to the root directory, open your shell of choice, and run uvicorn src.backend.main app. This opens up the a server of sorts, which, apologies, it's gone to my other monitor. As you can see, it shows off all of our work thus far, including, and it would have acted as our front end. However, unfortunately, we were unable to get the API working in time. As you can see here. But still, this is one of our many parts to this project. Welcome to the stenography section of the video presentation. In this section, I will explain and demonstrate the stenography encoder and decoder. To start, please enter the README branch in our repository. This is where the functional script is located, as the script in main is bugged. Now open main.py using your text editor of choice. And scroll to the very bottom. In here, you can now choose a certain passcode, which is the secret key, which will be used to encrypt your data. In this case, let us do hello, let's say, as the passcode, and the message shall be world. Similarly, we will change the decryption password to also be hello. The way this script works is it takes the input image, in this case image.png, which is once again Van Gogh's Starry Night, and it proceeds to encode the data onto a new image and then decode from the new image generated. So it does the encoding and decoding process all in one. Now that we have modified the data at the bottom here to fit what we want it to do, we can save. We can open up our shell of choice. In my case, I am using Poetry. And from here, we can run the program. As you can see, a new image has been generated, which hides data which hides the data hello, or world in this case, in the original image. We can also see that the message has been decoded from the new image. Thus concludes the stenography section of the video presentation. Welcome to the Fourier portion of the video presentation. In this section, I will explain and demonstrate the Fourier encoding and decoding process. First, to access the Fourier series work, please enter the Fourier Stuff branch. Next, navigate to the Fourier directory and open the main.py file with your editor of choice. Once here, please edit the message and image values to encode where message is the message you would like to encode. In my case, I shall use hello world, and where image links to the image in your directory. Please allow me to just get that. There we go. Now we have got the starrynight.jpg image, the Van Gogh painting, and we shall link to that here. There we go. Now we just save. Now we can open our shell. In this case, I shall be using the Poetry shell. You can set this up by following the instructions on our GitHub page. There we are. Now we can run the encoding script, done by running main.py. Here we are. Our encoded image is saved as a .tiff file. From here we can now begin the decoding process. We shall do this by using Fourier transform decoder.py. In the same shell, we shall use Fourier transform decoder.py. Into the watermark text that was used for encoding. In this case, we shall type in hello world and the path to the watermarked image file. So we shall just copy its path. I believe I forgot to take out the quotations. Excuse me. There we go. And now that the data has been extracted, the extracted text from the red channel is indeed hello world. This concludes the Fourier section of the video presentation. Welcome to the datastamp portion of the video presentation. In this section, I will explain and demonstrate the datastamp generation and decoding process. Please note, the datastamp generation software returns a pil.image object as part of a front-end integration system that we were ultimately unsuccessful in creating. It is, however, possible to manipulate the datastamp generation and decoding software from the IDE. Simply open your chosen IDE and run the program. Please ignore the first few prompts, as they are a deprecated feature. Once you are past the first few prompts and are now in the shell, type in string or str to image, followed by an open bracket, and then the string you would like to encode within the image. In my case, I shall use hello world, followed by a thumbs up emoji. I shall also save this to a variable which I shall call im. As we can see, we have a pil.image file or variable saved under im, and now we can save this using save. We shall call this hello.png. Please note that if an error is raised, then the string you have inputted is too large to be encoded on the datastamp. Once you've generated your datastamp, please save the image, and now we can begin the decoding process. Simply run the image decoding.py script and input the image path when prompted. As you can see, the original string has been decoded from the datastamp. We believe this fits to the theme of secret codes, as the datastamp can encode data in an unusual way, which someone may not expect to be, which someone may look at and not expect to be harboring data. Furthermore, the datastamp can even be read from an image taken from your phone. For best results, please use the lowest zoom out setting as you can, along with a 1:1 aspect ratio. I shall now demonstrate. I have now just taken a photo of the hello.png file that we generated and uploaded it to my computer. This photo has been taken from my phone, and you should be able to run it into the decoding software, and it should handle it just fine. Or not. So, I have taken a photo of the code, and I've uploaded it into the same directory. As you can see here, this was taken of my this was a photo taken of my monitor. However, you could also theoretically print out this code and do it that way as well. All we need to do is load it into the image decoding software as photo.jpg, and it gets decoded into Hello World. It does take a second, but it can decode from photos. This you may need to try a few times with a few different photos, as it's a little bit temperamental sometimes, unfortunately. But generally, for best results, if you use a 1:1 aspect ratio camera photo, and get a white background, then it should all be fine. That's the more important bit, actually, the white background. We thank you for watching this video, and hope you have a good rest of the day.